Hi, and welcome to our presentation on Hadoop and MapReduce. My partner, Dalen Fernandez, and I, Danielle Shelton, have taken a course in database management systems at Pace University. Over the course of the semester, we have done research on Hadoop, HDFS, and MapReduce. We will be discussing a brief history of Hadoop, give an overview of what HDFS and MapReduce are, some uses of Hadoop, and an example of code. In 2005, Doug Cutting and Mike Caffarella created Hadoop while working on the search engine Nutch. It was originally developed to help with the distribution of this. 1 year prior, in 2004, Google had released a paper on its Google File System, GFS, and its own MapReduce. Hadoop Distributed File System, HDFS, and Hadoop's MapReduce are based on this paper. At the time of Hadoop's creation, Mike Cutting was working for Yahoo, and so Yahoo was one of Hadoop's biggest contributors and earliest users. Hadoop is a batch processing system written in Java. It is made up of HDFS and MapReduce. Hadoop is a product of the Apache Software Foundation. It allows applications to work with thousands of nodes and petabytes of data. A key benefit of Hadoop is it allows you to send work to the nodes where the data actually exists, rather than the other way around.
Some uses of Hadoop include search indexes at Google, Yahoo, and Amazon. Amazon's Elastic MapReduce provides a managed, easy-to-use analytics platform built around the Hadoop framework. It is used in machine learning and data mining applications, and for analyzing user logs, data warehousing, and analytics. HDFS is a primary storage system capable of storing large number of large files. There are two types of nodes operating in a single HDFS cluster. The name node is a dedicated server that manages the file system tree and the metadata within the tree. There is only one name node per cluster, and it acts as the master or manager. The data nodes are servers that store application data and a copy or some or all of the blocks in the file system. There are multiple data nodes within each cluster. Since application data is stored on multiple data nodes, typically three, loss of a single data node is not fatal to the cluster. It can also be programmed in a number of languages such as C++, Java, and Python.
MapReduce is a programming model for large-scale data processing. It is broken down into two main tasks, map and reduce. One MapReduce job has three phases: map, shuffle, and reduce. In the map phase, the input data is divided up into data chunks, and then each of these are fed to an individual map task. Each map task applies the map function to its own input data and creates an output data set, which are intermediate key value pairs. During shuffle, the map outputs, or intermediate key value pairs, are taken to the reducer as inputs. During the reduce phase, there is a sort and merge of intermediate data. Then the reduce task applies a reduce function to the sorted data, which gives us an output for each reducer. These these are the visuals of what we've explained in the previous two slides. They will help you to understand the concepts better. For example, with MapReduce, you can see all three phases: map, shuffle, and reduce.
For HDFS, let's assume that we have data of 150 MB of a text file called mydata.text. In HDFS, when a file is loaded, it is split into chunks which are called blocks. The default is 64 MB. Each block can be given a unique name, which is block 1, block 2, block 3, etc. The 150 MB data is broken into three: 64 MB, 64 MB, and the third 22 MB to make the 150 MB file again. Each part of the broken data will be written into the cluster. Now, there is a piece of software running on a separate machine called the name node. The information stored on the name node is called the metadata. This is a demo code that we have written in Python to explain the working of MapReduce. The first is the mapper code, which does a count of the words used, excluding the spaces. It takes in the input from standard input and writes the result into standard output. The second is a reducer, which gives us the final count of the number of times each word was used. This also takes in the input from a standard input and outputs it on a standard output. So we pulled out a wiki search on Pace University, and this is a snippet of that. The mapper code should give us a count of each word, and the reducer will give us an idea as to how the data is stored in these nodes. These are the outputs for the codes. As you can see in the mapper file, we've got all the words that we used within the text file listed down. If you look at the reducer code, you can see that pace was listed 4 times, the word new was mentioned 2 times, and the lowercase a was mentioned twice. Similarly, the uppercase a was mentioned once. This is an example of the reducer code.
Finally, you'll find a list of our references. The first four are all from the ResearchGate website, and the last is a site that we used when working on our code. So this is everything that we use to do our project. Thank you very much for taking the time to watch our presentation.